Hello, today's screencast is all about tensile test definitions. So, when learning about engineering, there's a whole bunch of new concepts that you probably haven't heard of in, say, any of your science classes before. So, this video is all about defining some of those new terms. However, if you need help reading values off of a tensile test, there is a separate video up here. The link is up in this corner. And if there's a particular definition that you need, there are a bunch of hyperlinks down there so you can get to the definition that you want. So let's get started. Our first two definitions are engineering strain and engineering stress. Now, engineering strain is defined as the change in length divided by the original length. This is mathematically represented over here, and the symbol that we use for strain is a lowercase epsilon. Engineering stress is defined as the applied load divided by the original cross-sectional area. It is showed mathematically over here and is symbolized by a lowercase sigma. Now here is an example stress strain curve that I'm just going to draw. So here we go. Like that. So in a normal stress strain curve, stress is going to be on your y-axis like that, and strain is going to be on your x-axis like so. Now let's talk about some units. For stress, we've got a force per unit area. So if we were doing it in American units, we'd probably have PSI, pounds per square inch, or if we were using, metric units, we would have newtons per meter squared, which is a Pascal, and again, with metric units, you can add prefixes to change the base power that you're using. Now, engineering strain does not have a unit because it's, a length divided by a length, so we could have, millimeters over millimeters, centimeters over centimeters, etc. So there are no units on engineering strain. Our next two definitions are Hooke's law and Young's modulus. Now, when a material goes through a tensile test, the first part of the curve produced by that tensile test is a linear portion because until a certain amount of stress, most materials behave elastically. Now, elastic means that the material will go back to the way it was after you stop applying that force or that stress. So, now having said that, Hooke's law tells us that force is equal to a constant, the spring constant, times displacement. Displacement can also be written as change in length. You may have heard of Hooke's law in your physics class, and it is related to Young's modulus, or capital E. Modulus of elasticity is the stiffness of the material when the material is undergoing deformation, specifically elastic deformation. So it is also known as the slope of the linear part of the curve right there of the stress strain curve. It's the slope of this linear portion right here, and it's a measure of stiffness. Now, the reason why I grouped these two together is because they are related. If we can rearrange Hooke's law to say that force over displacement, which I'm writing as change in length, is equal to a constant, the spring constant, right? So, now we can see that elastic modulus, so E, is equal to change in stress over change in strain, which is equal to, if we go back to our first slide, force divided by the original cross-sectional area over, that entire thing, over change in length divided by the original length, which is represented here as L sub 0. Now, if we multiply both sides, right, we can see that this is just a constant down here. These are both constants, and that the spring constant and Young's modulus are only a constant away from each other. So that's why I put them together. Our final set of definitions are things related to the actual tensile test. So either things that we can calculate from the stress strain curve or things that are just simply related. So Breaking strength, tensile strength, yield strength, and percent elongation are things that we can read directly from a stress strain curve. However, percent reduction of area, we can't. So, if you understand the definitions of these things and you just want to see a calculation for these things, I have another video for that. The link is right over here. It actually goes through the calculations. But right now I'm just going to tell you what they are and show you about where they would be on a normal stress strain curve. So, the breaking strength is the amount of stress a material can withstand before breaking. So, if we look at a stress strain curve, it would be the y value at this point over here where the material breaks, the curve ends. So the stress value here. Now, the next definition is tensile strength, and the tensile strength is the maximum amount of tension a material can withstand. It is a stress. It is a stress also, and it's the topmost point of the curve. So going back here, the tensile strength would be this x right over here. Okay. Our next definition is yield strength. Now, yield strength is plastic deformation that occurs at a specific amount of stress. So, a lot of times you can't really tell when plastic deformation begins to occur in metals a lot of times. So what many engineers will do would be to find the strength at a arbitrarily picked percent strain. So most of the time it is 0.2%. Sometimes it's 0.1%, but either way, it's where you can see plastic deformation happening. So that's a pretty good general definition. Yield strength is generally where you can see plastic deformation happening. And going to a stress strain curve, the yield strength on this stress strain curve is represented by this light blue X, the stress value here. Again, in reality, this would be much closer in the point. That would be much closer in. However, for you to see it better, this is what it would look like. Again, if you want to see a calculation of it, go to that link. I go through a big calculation of it. Our final value that we can find from the stress strain curve is percent elongation. Now, by definition, it's the change in length divided by the original length times 100. Now, on the stress strain curve, it is not the value that's directly below the breaking strength. It's not that. It's actually this way because we go and we take into account elastic deformation. So again, go to this link if you want to see a calculation. So it'll be down there. It'll be given as a decimal down here, and then you'd have to change it into a percent to find the percent. Okay, so finally, the percent reduction of area is not something you can find off of a stress strain curve, but it's something that you can calculate. It is by definition the original area minus the final area, that entire thing divided by the original area times 100. Now, I did a calculation for this again up here, but that is the definition, and basically what it's saying is that when you pull something, when you perform a tensile test on a material, the cross-sectional area will decrease because of necking. So this is the exact amount that it decreased. So I hope this video has been informative and has helped you to learn about tensile tests, and if you have any questions, leave them in the comment section. I mean, if you want to see the calculations again, watch this video up here, not this one. So, thank you so much, and have a good day.